Welcome everyone to the course of Maintenance and Testing of Electrical Machines. I am Dr. Prashant Kumar Jaina, Assistant Professor in the Department of Electrical and Electronics Engineering. Today, we will discuss one of the important topics on maintenance of power lines and cables. So, let us start now. So, we all are so addicted to the electricity and simultaneously we do not realize what would be if there is no electricity and how it all are maintained. Imagine a world where the lights never flicker, where your devices are always charged and where power outages are a thing of the past. It's easy to take electricity for granted, but behind the scenes, a complex network of power lines and cables work tirelessly to keep our lives running smoothly. Today, we will explore the fascinating world of power line and cable maintenance, a field where academic concepts meet industrial challenges. Whether you are an aspiring engineer or just curious about how to stay grid strong, the session will give you the knowledge you need and maybe even inspire your future career. So, we will see first the power cables is the backbone of power distribution. So, let us start by understanding the role of power lines and cables in the electric grid. These components are the backbone of our power distribution system, carrying electricity over vast distances from power plants to our homes, schools as well as industries. Power lines, typically overhead and underground cables, often buried in the underground or overhead lines, must endure harsh environmental conditions from scorching heat to freezing cold, all while maintaining the reliability of the power supply. So, let us take an analogy for our better understanding purpose. Think of power lines and cables as the veins and arteries of our electrical system, just like in a human body. Just as blood vessels carry nutrients to every part of our body, these lines carry electrical energy to every corner of the grid. And just like in the human body, any blockage or break in the system can lead to serious problems. So, these power lines and cables are very much important in transmitting power to from power plant to our home. So, what is the necessity? Why maintenance matter, or is it something for an optional choice? So, why is maintenance so crucial? So, we will consider this. The average power line is expected to last for decades, but only if it is maintained properly. It is not like a mobile or any electronic gadget that we use today and replace within a couple of years. Hence, without regular upkeep, these lines can suffer from corrosion, wear and even catastrophic failures. Maintenance is not just about fixing things when they break, it is all about preventing problems before they happen. In other words, maintenance deals with the prevention mechanism. So, let us take a case study. Take for example, the 2003 North American blackout, one of the largest blackout in the history. A power failure in maintaining a section of the grid led to a cascading effect that left 50 million people without power. This incident highlighted the critical importance of regular inspections and proactive maintenance. Now, let us see different types of maintenance. So, first we will see the types of maintenance. So, maintenance strategies can be divided into four main types. First, preventive, then predictive, corrective and condition based. Each of these approaches has its unique purpose and methodology, and understanding them is the key to keeping the grid running smoothly. So, let us go to one by one, the categories of maintenance one by one. First, we will see the preventive maintenance. Preventive maintenance is all about anticipation. This strategy involves routine inspections and scheduled upkeep to catch potential problems before they cause outages. Imagine it as going to the doctor for regular checkups. Even if you feel fine, those visits or regular blood testing or diagnosis can help you to detect and prevent health issues early. So, what are the procedures carried out for the same or for keeping the maintenance. The key procedures in preventing maintenance. First one is visual inspection. Engineers regularly inspect power lines and cables for signs of wear, corrosion or physical damage. This can be done using binoculars, drones or even helicopters for larger networks. We know power network is very vast and complex infrastructure which cannot be done by human activities. Key indicators in this case include rust, sagging of lines or damaged insulators. Next we will see thermographic scanning. Thermal imaging cameras are used to detect hot spots that could indicate failing of components or overloaded circuits. This is crucial in identifying potential failures before they happen. Next one, electrical testing. This includes insulation resistance testing and continuity checks. Regular testing ensures that insulation on cables and lines is intact and that the electrical pathways are unobstructed. Now, what are the importance of doing this? The importances are, it prevents unexpected failures by identifying the issues early. It extends lifespan of the infrastructure, and finally, it ensures continuous power supply, which is critical for both residential and industrial consumers. So, what are the pros and cons of doing this? The pros include early detection of wear and tear, reduced risk of unexpected outages, extended lifespan of the equipment. What are the cons? The cons can be time consuming and labor intensive. Sometimes it may involve or require service interruptions. So, let us take some real world examples. Utilities like Southern California Edison regularly deploy drones equipped with high resolution cameras to inspect their power lines. These drones can identify issues like fraying cables or leaning poles long before they become serious problems. This will allow them for timely repairs. Next, another type of maintenance will go, that is called predictive maintenance. Predictive maintenance takes things a step further by using data and advanced analytics to predict when a component might fail. It's like having a fitness tracker for the power grid, constantly monitoring vital signs and alerting you for the any kind of potential problems. So, what are the key procedures that is used in the predictive maintenance? First one is your condition monitoring. Sensors are installed on power lines and cables to continuously monitor parameters such as temperature, vibration and electrical load. Any deviation from normal conditions can indicate an impending failure. Next, we will see vibration analysis. Power lines and cables, especially in high wind areas, can vibrate, leading to mechanical stress. By analyzing these vibrations, engineers can predict when and where wear and tear might occur. Next, data analytics. Historical data from sensors is analyzed using machine learning algorithms to predict future failures. This allows for targeted maintenance, reducing both cost as well as downtime. Next, we will see the importance of this. The importance includes it allows for more precise and timely interventions. It reduces unnecessary maintenance, thus saves some cost. It enhances the reliability of the power grid by addressing issues before they lead to failures. Next, we see what are the pros and cons. The pros are the more targeted maintenance, it minimizes unnecessary work, it is cost effective in the long run. What are the cons? It requires investment in technology and data infrastructure. It can be sometimes complex to implement. Next, we will see some case study. Excel Energy has adopted predictive maintenance across its network, which resulted in a 20% reduction in maintenance costs. By analyzing data from sensors placed across or along the transmission lines, they can pinpoint exactly when and where the maintenance needed, preventing failures and before they occur. It allowed them to prevent some failures that may occur. Next, we will see the corrective maintenance. Corrective maintenance is reactive. It is performed after an issue has been detected, often in response to a failure. Think of it as an emergency surgery as necessary part, but ideally something you want to avoid through preventive measures. What are the key procedures in corrective maintenance? First one is fault location and isolation. When a fault occurs, the first step is to locate it using the fault detectors or analyzing the electrical characteristics of the line. Once it is located, the affected section is isolated to prevent further damage and restore service to the unaffected areas. Second one, repair and replacement. Damaged components such as insulators, conductors, or even entire sections of the cable are repaired or replaced. This might involve splicing the cables, replacing the insulators, or even erecting new poles or towers. Third one is system restoration. After repairs are completed, the system is tested to ensure it's functioning correctly before they being brought back to online condition. Then what is the importance? The importance include it is essential for restoring the power after unexpected failures. It helps to minimize the downtime and service disruption, and it ensures the safety of the power grid by quickly addressing the faults. So, what are the pros and cons? The pros include it directly addresses the issues as they arise. It is necessary for unexpected failures. What are the cons? It can lead to extended downtime or often more expensive due to the urgency. In the real time scenario, if we see, after a major storm in 2017, Florida Power and Light had to perform corrective maintenance on over 4,000 miles of damaged power lines. The quick and the effective response was critical to restoring the power to millions of residents. Next, we will see condition based maintenance. Condition based maintenance is a blend of previous strategies. It involves performing maintenance only when specific indicators suggest when it is needed. This approach ensures resources are used efficiently without compromising the reliability. What are the key procedures that is used in the condition based maintenance? First one is continuous monitoring. Similar to the predictive maintenance, sensors are used to continuously monitor the health of the power lines and cables. The difference here is that maintenance is performed based on the current condition rather than the predictor failures. Second one is threshold based action. Maintenance activities are triggered when certain conditions are met, such as a temperature threshold being exceeded or a specific vibration pattern being detected. Third one is adaptive maintenance scheduling. Based on the real time data, maintenance schedules are adjusted dynamically, ensuring that resources are used effectively without compromising the integrity of the power grid. Next, we will see what are the importance. It maximizes the efficiency of maintenance activities. It reduces unnecessary work, focusing only on the components that need attention. It helps to extend the lifespan of power lines and cables by preventing premature failure. Next, we will see the pros and cons. In pros, we see it is highly efficient, it reduces unnecessarily maintenance work, it extends the life of components, whereas in cons, it requires sophisticated monitoring systems and sometimes it is costly to set up. In case study, if you see, in Germany, E.ON's implementation of condition based maintenance led to a significant reduction in both operation cost and unplanned outages. By continuously monitoring the health of high voltage cables, they could precisely target maintenance effort where they were needed. Next, what are the specific maintenance procedures? So, let us dive deeper into some specific maintenance procedures that are crucial for keeping power lines and cables in optimal conditions. These procedures are the hands-on actions that ensure the grid's reliability and safety. So, we will see insulator cleaning and maintenance. Insulators are critical components that prevent electrical current from flowing to the ground through the poles and towers. Over time, they can become contaminated with dust, pollution and even salt from the sea, leading to potential failures. So, what is the procedure? First procedure is inspection. Regular visual inspections are carried out to assess the condition of insulators. Any signs of contamination, cracking or damage are noted for further action. Second one, cleaning. Insulators can be cleaned using water, steam or even by hand using specific tools. In areas with severe contamination, helicopters equipped with cleaning rigs may be used to reach high altitude insulators. Third one is your replacement. Damaged insulators are replaced promptly to prevent electrical arcing and potential outages. Next, we will see what is the importance. It prevents electrical arcing and flashovers. It ensures the integrity of the electrical insulation. It reduces the risk of power outages due to insulate failure. Next, what are the pros and cons? In pros, it is essential for maintaining system reliability. It can be done without de-energizing the line in some cases. In cons, it can be labor intensive and require specialized equipments. In case study, we will see in coastal regions of California where salt contamination is a significant issue. Pacific Gas and Electric regularly cleans insulators on their transmission lines. This proactive approach has drastically reduced the number of power outages that is caused by the insulation flashover. Next, we will see the conductor maintenance. Conductors are the actual carriers of electricity across the grid. Over time, they can sag, corrode or even break due to environmental factors and mechanical stress. Ensuring their integrity is vital for continuous delivery of the electricity. Next, we see the procedures. First is that sag and tension monitoring. Conductors are regularly checked for sag, which can occur due to thermal expansion or mechanical stress. Proper tension must be maintained to prevent sagging of lines from coming into contact with trees or buildings. Second, we will see corrosion inspection. Conductors, especially in industrial or coastal areas, are prone to corrosion. So, regular inspections using both visual and chemical analysis help us in identifying the corrosion early. Third one, repair or replacement. Damaged sections of conductors are either repaired through splicing or completely replaced. In some cases, entire spans of conductor may be restrung to restore proper tension and alignment. Next, we will see what are the importance. The importance include it prevents power outages caused by broken or sagging of lines. It ensures safe clearance from ground and nearby structures. It extends the lifespan of the transmission infrastructure. So, in pros and cons, we will see the pros include it enhances the system reliability. It prevents accidents caused by sagging or broken lines. In cons, we will see it requires specialized equipment and trained personnel. Sometimes it can be disruptive, especially if lines need to be de-energized. In real-time example, we will see in 2020, the Tennessee Valley Authority undertook a massive conductor maintenance program to address sagging and corroded lines across their network. This program significantly improved the reliability of the grid, particularly in rural areas which is prone to severe weather conditions. Next, we will see the vegetation management. Vegetation management is a critical aspect of maintaining overhead power lines. Trees and other vegetation can be interfere with power lines, which leads to outage of lines and even catastrophic failures. So, what are the procedure is carried out here? First is that regular inspections. Vegetation near to power lines is regularly inspected to ensure that tree and shrubs do not encroach on the minimum clearance distance required for the safety. Next, we will see the trimming and removal. Trees that are too close to the power lines are trimmed or removed. In some cases, selective herbicides are used to prevent regrowth, though this must be done with the environmental considerations in mind. Use of technology. LiDAR, that is called light detection and ranging. This technology is increasingly used to map vegetation and identify potential risks. This allows for more precise and efficient vegetation management. Next, what are the importance? The importance is that includes that it prevents outages caused by trees falling on the power lines. Second is that it reduces the risk of wildfires, especially in dry regions. And third is that it ensures compliance with safety regulations. We will see the pros and cons. In pros, it is essential for preventing power outages and fire. It can be done proactively to avoid emergency situation. In cons, it can be labor intensive and expensive, and it requires careful planning to avoid environmental damage. In the case study, we will see after the devastating wildfires in California in 2018, utilities like Pacific Gas and Electric have ramped up their vegetation management programs. This includes more frequent inspections, aggressive trimming schedules, and the use of advanced mapping technology to prevent future disasters. Next, we will see the safety and regulatory considerations. So, safety is paramount in the maintenance of power lines and cables. Working with high voltage system presents inherent risks, and strict safety protocols must be followed to protect both the workers and the public. So, what are the safety procedures that is carried out? First is that lockout or tag out. So, what is called LOTO, L-O-T-O. Before any maintenance work begins, the affected section of the power line is de-energized and locked out to prevent accidental re-energization. This ensures the safety of the maintenance personnel. Second one, personal protective equipment. Workers must wear appropriate PPE kit, including insulated gloves, hard hats, safety gloves, and flame resistant clothing to protect against any kind of electrical hazards. Third one is your grounding. Temporary grounding devices are installed on power lines to protect workers from electrical shock if the line is accidentally energized. Next, fourth one you will see the safe work practices. This includes maintaining a safe distance from live lines using insulated tools and following proper procedures for climbing poles and towers. So, what are the importance? It protects workers from electrical hazards, it prevents accidents and fatalities, it ensures compliance with occupational safety and regulations. What are the pros? In pros, it is essential for worker safety, it reduces the risk of accidents. In cons, we will see that it can be time consuming to implement, it requires regular training and compliance check. In case study, you see after a serious accident involving a power line worker, the Australian energy market operator introduced enhanced safety training and stricter safety protocols. As a result, they saw or observed a significant reduction in the workplace accidents. So, next we will see the environmental and regulatory considerations. Maintenance activities must also consider their environmental impact and adhere to regulatory standards. This includes managing waste, controlling pollution and protecting wildlife habitats. So, what are the environmental measures? First one is your pollution control. So, proper disposal of hazardous material such as old oil from transformers or contaminated soil from excavation is critical to preventing environmental contamination. This involves following strict disposal protocols and using approved waste management services. Next, we will see vegetation management. As discussed earlier, vegetation management must be done in a way that it preserves natural habitats. This may involve avoiding work during nesting seasons or using environmental friendly herbicides. Next, regulatory compliance. Maintenance activities must comply with a range of regulations, including those set by environmental agencies or safety organizations and local governments. This ensures that maintenance work is done responsibly and suitably. So, this is what are the importance? It protects environment and public health, it ensures compliance with legal requirements, and enhance the public trust and corporate responsibility. The pros include it protects the environment, it prevents legal issues and fines, and it builds community trust. Cons, it can be time costly and time consuming, it requires careful planning as well as execution. Next, we will see what are the future trends and innovations. The field of power line and cable maintenance is evolving rapidly with new technologies and innovations paving the way for more efficient and effective maintenance strategies. So, we will see first smart grid technology. The first one comes real-time monitoring. The future of maintenance lies in real-time monitoring systems that use sensors continuously to collect data on the condition of power lines and cables. This data is transmitted to the control center where it is analyzed in real time to detect any anomalies. Second, automated maintenance. Innovations like drones, robotics and automated inspection systems are being developed to carry out routine maintenance tasks. These systems can operate in hazardous conditions, which reduces the risk to human workers. Third one, data-driven insights. With the rise of big data and artificial intelligence, maintenance strategies are becoming more predictive and data-driven. Artificial intelligence algorithms can analyze vast amounts of data to predict when and where maintenance is needed, which optimizes resource allocation and which reduces the costs. The importance of this are, it will enhance the efficiency and effectiveness of maintenance activities. It will reduce the need of manual labor, especially in hazardous conditions, and it improves the reliability and resilience of the power grid. The pros comes that it increases the efficiency as well as accuracy, it reduces human risk in hazardous area, and it optimizes resource use and reduce costs. Cons are that it requires significant investment in technology and it can be complex to implement and manage. Next, we will see the conclusion. Maintenance of power lines and cables is not just about keeping the lights on, it is about ensuring the safety, reliability and sustainability of our power grid. As we have seen today, this field combines the cutting-edge technology with hands-on expertise while offering a challenging yet rewarding career path. Whether you are interested in working in the field, designing a new maintenance technology or analyze data to predict the future failures, there is a place for you in the critical industry. So, thank you for joining us on this journey through the world of power lines and cables and maintenance. We hope this session has sparked your interest and provided you with the knowledge you need to succeed in your future endeavors. Remember, the power of tomorrow is in your hands. So, as we transition from critical task of maintaining power lines and cables, which ensures the reliability of our electrical infrastructure. It is essential to address the environmental impact that such maintenance activities and industrial activities at large can have. The next topic we will see preventive measures to control environmental pollution, builds on our previous discussion by focusing on how industries including the power sector can minimize their ecological footprint. This environmental pollution is a pressing global issue that affects every aspect of our lives, from the air we breathe to the water we drink. In the context of power line and cable maintenance, pollution control involves careful management of waste, emissions and other environmental impacts associated with the operation and upkeep of electrical infrastructure. Preventive measures are critical to reducing pollution at the source. So, safeguarding natural habitats and ensuring compliance with environmental regulations. This discussion will explore various strategies that industries, particularly those involved in energy production and distribution, that can implement to mitigate their environmental impact. We will delve into the importance of pollution control strategies, sustainable practices and proactive regulatory compliance. The goal here will be to provide a comprehensive understanding of how to balance industrial progress with environmental stewardship, which while ensuring a cleaner and healthier planet for our future generations. As we explore these preventive measures, we will also consider real world examples and case studies to illustrate the effectiveness of these strategies in controlling environmental pollution. Thank you.